Hi, welcome to our next level 1 tables, equations and graphs video. We're going to introduce linear functions for a few videos, and the first part of this is to talk about positive gradients. Now the gradient of a line is a number that determines how steep the line is. The larger the number is, the steeper the line is. Here's some examples of different lines that all have different steepness or gradients. Now the gradient is equal to the rise over the run. The rise is how far we move up and down, and the run is how far we move left and right. Now you remember the idea of coordinates, which is numbers inside brackets. The first number is the x direction going across horizontally, and the second number is vertically. This new idea of gradient is different. We talk about rise first over run second. So just try not to get those two ideas mixed up, please. Right, straight into example 1. This line has a gradient of 3/5, 3 over 5. So we're going to pick 2 points on the grid, and we know to get from one point to the other, we must rise up 3 squares and run across 5 squares. So we rise 3, run 5. Now it doesn't matter which 2 points I had to pick, so long as they are on the grid, where the 2 grid lines intersect. To get from one point to another, we must rise up 3 squares and run across 5 squares. Right, here's example 2. This line has a gradient of 1/8, 1 over 8. So I'm picking 2 points that are on the grid, and we must rise up 1 square and run across 8 squares. So rise up 1, run across 8. So I'm putting example 1 and example 2 onto the same grid right now. The bottom line is example 1, which had a gradient of 3/5, rise 3, run 5. The top line had a gradient of 1/8, 1 rise 1 and run 8. Now, if I converted both of them into a decimal, 3/5 converts into 0.6 because I go 3 divide 5, and 1/8, I can go 1 divide by 8, and that gives me the decimal 0.125. Now, 0.6 is greater than 0.125. So the decimal 0.6 is greater, so 3/5 is greater than an eighth. Because 3/5 is greater, then it's the larger number and it's the steeper gradient. And you can see visually that the gradient that has 3/5 is steeper. It would take a little bit more energy to walk up that hill than it would walk up to a hill that has a gradient of 1/8. So the larger the number is, the steeper the line is. Right, example 3. This line's got a gradient of 3. Now 3 has to be written as a fraction, and we do that by writing it over 1. 3 divided by 1 is still 3. So now let's pick 2 points on the grid and go up 3, rise 3, across 1. So rise 3, run 1. So anytime you see a gradient that is a whole number, for example 4, 9, etc., we just need to write the gradient as a fraction over 1. So the gradient of 4 is the same as rising 4 and running 1. Right, what about example 4? This line has a gradient of 1.5. It's a decimal. Now I could write it as 1.5 over 1, which means I rise up 1.5 squares and I run across 1 square. But I like to do a little trick. I'm going to double the top to get 3 and double the bottom to get 2 to get a fraction that does not have decimals in it. So I've got 3 over 2, and that tells me, I know 3 divided by 2 is 1.5, but that tells me it rises 3 squares and runs 2 squares. What about drawing a line with a gradient of 5? Well, let's come back to the idea that a gradient of 5 is 5 over 1. Any whole number is over 1. So now I just need to start somewhere on my grid and rise up 5 squares and run across 1 square. Right, quick thing to finish off with. Here's a line. Let's work out the gradient. We rise up 2 squares and run across 3 squares. But some other person might have picked 2 other points and said, no, the gradient is 6 over 9. Rise 6 and run 9. Well, that's okay. You're both right. That's because the gradient of 2/3 is equivalent to the fraction of 6/9. So it's the same number, same gradient. Right, well, that's us for this first positive gradient video. Thanks for watching.